Hi everyone, Brightbone here, and today we're going to take a look at Kerberoasting. Kerberoasting, very common attack, very useful if you can get it to work, and also most environments are still fairly vulnerable to this or are fully vulnerable to this type of attack. All you need in most environments is a username that is part of Active Directory, either a host that's logged into the network or the username and password of a particular user account. It can be any user account in the Active Directory because it's base functionality. So what we're going to take advantage of is in Active Directory, when a service account is assigned a service principal name, that service principal name hashes the password of the account into a specific requestable type. That type being requestable can then be pulled in by any user and then decrypted, right? This is a really cool attack. It was figured out by Tim Medine. Really kind of changed the face of how Kerberos was being taken advantage of. But now there's tons of tools out there that do Kerberoasting. There are just multitudes. But what we're going to look at today is we're going to look at the PowerShell way, Invoke-Kerberoast. We're going to look at Rubeus, and then we're going to look at GetUserSpns.py from Impacket, which is embedded in Kali and in a bunch of other different releases from the Linux side. But what we're going to notice is that when we're doing these attacks, it's actually going to change the log. And this is the first I'd seen this a few months back when I was experimenting with this. Depending on the tool that's run or the method that's run, the ticket option in the log will change. So when you're building your rules, don't just read articles, test. Because if you're not testing effectively, you're not going to be able to catch these attacks. All right, so let's start with our typical user Clint Barton here. We're going to, attack Hawkeye once again, or this scenario, we're actually going to use Hawkeye to attack the domain controller, right? So let's start. We're going to start with PowerShell. We'll just go into PowerShell. We'll clear our screen. And we're going to do our normal AMZ bypass here, which we've had pretty good luck lately with this. So there we go. AMZ bypass worked. And now we're going to invoke Kerberoast from, we're going to essentially do a download cradle to get invoke Kerberoast from the Empire project, right? And in most environments, this will just work. They don't block GitHub or raw.github user content. If they did, you can host it up on Amazon or any kind of Git library on the net, anything that you can do HTTPS from. So let's go ahead. We'll get invoke Kerberoast. And there it goes. So if we do, I want to do this first. I want to do klist and look at the tickets we have because I did this attack earlier and I want to clear them. So I'm going to go klist, purge, just to make sure it generates a new event, clear. And then we're going to do invoke Kerberoast. Just right here to the screen, just invoke Kerberoast. And there is our SPN hash of the IIS service account. So as you can see here, CN equals IIS service account. This is the SPN hash for the IIS service account. And here it is the service principal name. And that's where that term SPN hash comes from, service principal name hash, right? So this is great. We can take this and put it in hashcat format, but I typically prefer just to do the output in hashcat format right from invoke-Kerberoast. So let's do that just so you guys can see it. Oop. Let me copy and paste that in the right way. And it doesn't want to do it. Sometimes I have to. There we go. So now we can see Invoke-Kerberoast output format hashcat, right? It knows how to output in hashcat format. You then do select object expand property and hash. And then you go out file and encoding ASCII and kerb-0.txt or whatever file name you want to give it, right? I usually use like kerb hash, whatever, 1, 2, 3, 4, or 5. So we'll go ahead and do this, and then it will have created a file in the directory that we just ran the tool from. And then if you type it out, you can see the differences here, just curb #0.txt. And notice instead of it just showing this, it has a $23 here. The $23 signifies the RC4 cipher and the hash type, right? So we can see the account name, hacklab.com. This is all on one line, so it's perfectly useful for hashcat, right? Hashcat is expecting everything to be on one line. So great, we have done our Invoke-Kerberoast. So let's clear screen real quick, and then I want to hop over here to our Elastic SIEM, and let's take a look at event code 4769. So event code 4769 is the event where you would see a Kerberoast occur. So if we click on this, and we're just kind of guessing that this is the right event for the Kerberoast, that is not it. This looks right, but I think we're on the wrong page now. That's correct. So this is it. And what we'll see is a Clint Barton's account here. That's the account name that requested the service information of IIS_service, the IP that it came from. This is the IP of the host, and this ticket type 0x40810000. Now, this is the important part. The ticket encryption type of 0x17 means RC4. If this is a 0x11 or a 0x12, it is an AES-based cipher, which means it's much, much harder for an adversary to crack. You still want to use long passwords, right? You don't want to use short, simple passwords and rely on encryption. But you want to make sure that any place in your Active Directory that's outputting this 0x17, and you can't change that, that you're using a really, really long, hard to crack password. The failure code also is 0x0. It will always be 0x0. Now, like I said earlier, the ticket options, depending on the tool you run, will change. So in this case, we see 40810000. Now we're going to go run Rubeus and see if it makes a difference. It may not, but we'll also run GetUserSpns.py from Impacket, and I know for a fact that will make a difference. So let's go ahead and we'll close out our SIEM here. We'll hop over to our Win10 host, and we'll get out of PowerShell because I don't need PowerShell anymore. I'm going to go ahead and cd into the desktop directory. And I'm going to use my version of Rubeus that we encoded in a previous video. Defender is on. This slips right by Defender because I've encoded it to a point that it can't be detected, right? If you're interested in that, go check out my Defeating Defender video. And so we're going to run Hagrid. And then we're going to go Kerberoast. And then we'll just do output hash.text. And I think that's it. I might need a slash. Nope, it did it. And there is our hashcat formatted output. And just to be safe, I'm going to go ahead and do another klist purge. I'm going to do klist purge. I'm going to run it one more time just to make sure it generated an event and we see a new ticket come in. So we'll run it again. And then we're going to do klist. And we should see a whole bunch of new tickets, but there's the one we were interested in, right? So let's go take a look at our SIEM now and see if Rubeus gave us any different view. So we'll refresh here and we'll see some new times come in. 1524. And notice what it looks like now. There's a missing 1 from what we saw earlier. 408 and then all zeros. So Rubeus is different than Invoke-Kerberoast. So most people's Kerberoasting rules are wrong. They're not accounting for all the tools out there, right? So this is why we test, and this is why one of the reasons I built this channel. is for testing these things and educating people on these particular things. Like you can read 15 different articles on the web, and it's not going to give you all of the information needed to create an effective rule here, right? One will say one value, another will say a different one. And we're proving that here. But this value is different than we saw from Invoke-Kerberoast. Same account, different ticket option, right? So let's take a look now at GetUserSpns.py. So we're going to pop over here to Kali and clear this real quick because I already did that once, but I want you guys to see it. And we're just going to run Impacket-GetUserSpns, hacklab.com, clint.barton, our target domain of hacklab.com, and we're going to do a request, right? We're requesting a Kerberoast ticket. Now on Kali, you need a password. So we're going to go ahead and give it the password of Clint's account. If you're testing from Linux, you can password spray or responder for literally any account in the domain, and you can do this particular attack against Active Directory. So let's go ahead and we'll run this, and it's going to ask us for a password. You can put the password into the command line too. I just don't like to do that because I'm afraid I'm going to ever, expose it in a report, right? And there we go. We can see now we have our hashcat formatted SPN hash. There it is. So let's take a look at our Elastic-SIEM one more time. We will refresh. Do we have any new values? We do. 15, 26, 33. And now another different value. 3 different attacks, 3 different ticket option values. Weird, huh? It really surprised me when I started messing with this. But these are the 3 most common ways I see pen testers do Kerberoasting. And that shows how unreliable most people's detection is here. You have to have all 3 values or you will not effectively detect this attack. So for fun now, let's crack the hash, right? Let's just show how easy this is to do. Pop over here directly to my MacBook. I'm running an M1 Mac. It's pretty simple MacBook overall. And we're just going to run hashcat here. Hashcat, we're going to do -o-m. 13100 is the type for a Kerberoast hash, so it is the type for that RC4 cipher for Kerberoast. Our kerb-hash0.txt, this is what I pulled off the Win10 host just a minute ago. We're going to use the hobo rules here. These are great. And then we're going to use the Rocky word list. And then I'm just going to do pot file disable because I already cracked it. I don't want it to just not do anything. I want you to see it. So let's run this. And you can see how fast this cracks. But why does it crack this fast? Because someone was dumb. These are made by humans. Humans do silly things. And in this case, someone thought it was a great idea to do password with a 0 for the O and an exclamation point at the end, and that's their password for this service account. People make bad passwords. They'll make bad passwords for service accounts just as much as they'll make bad passwords for the regular users. And admins are not immune to this, right? They're just not. It's very common to Kerberoast your way into domain admin. I kid you not. Now, this is a service account. It usually means I have higher level access than your traditional user. And you can, in a lot of cases, use this for lateral motion because not a lot of people control login the way that they should with these service accounts. All right, so that was fun, kind of just cracking it. But let's take a look now at how we stop this from happening. How do you stop this? There's a couple easy ways we can stop this. So if we pop over here to our domain controller, the best way is to use group policy. And if you take a look at our default domain controllers policy here, and I'll drag this over. Under security settings, local policies, security options, you have the option in network security, configure encryption types allowed for Kerberoast. We double click this, it gives us the ciphers that are allowed. You should only allow that one. So if I go define this policy, click this box, and then hit apply, I've now created a group policy that will fix this problem across the board. It'll move to the new cipher. it won't be 0x17 anymore. It'll be 0x12, which is AES, right? Now, if you can't do this for some reason, right, there is another method. That other method is by finding the user and then changing it at the user account level to be supported. This doesn't always work perfectly, and in some cases it still will generate the RC4 cipher. So be careful with this one. We'll go ahead and we'll find our IIS user. So we'll go IIS, and there's our IIS service account. And then we're just going to go into properties here. And under the account in general, you scroll down a little bit. You can see, wow, that's great. Password never expires. That's pretty common on a service account. And then you scroll down, and you'll see this account supports AES 256-bit encryption. If you check this box and apply, normally either on the next password refresh cycle or eventually it will land as a 256-bit AES cipher as a 0x12, then a 0x17. If you do this across the board, then you can create a fantastic rule just looking for anything using that ticket option of encryption type of 0x17. Then you can detect new attacks with that 0x17. Anything trying an RC4 cipher, which most of the hacker tools use that. So you might be able to grab something like skeleton key, which we can go over in a different video later. But RC4 cipher, you want to just turn that off across the board. All right, so let's go to Elastic SIEM. And I want to grab these ciphers here, these ticket options. So we're going to grab 0x408100010 and 000 across the board. So I'm going to go to my rule here. And you're going to notice my rule is actually wrong because I hadn't seen the 0 version of this before. The all zeros version previous to this. So I'm going to go edit rule settings. I'm going to come in here and I'm going to take my target. I'm going to do an OR and we'll go 0x48408 1, 2, 3, 4, 5. So notice the different versions we have. 0x408100010, 0x408100000, and then 0x408 all zeros. And then you want to do and not computer name, right? So go ahead and save our changes here. We'll take this query and we'll run it, and we should be able to grab all of our Kerberoasting attempts now. So we come back over here to discover. So we're going to do type when event because that's what when log beats pushed out. Type when event log and event code 4769 and when log event data ticket encryption type 0x17. So we only care about it if it's a RC4 cipher. And then when log event data ticket options are 3 ticket options and not $. So if we take a look here, we can see the different variants. 10010, all zeros, and then 10010 and all zeros. Do I see? Yes. So this is the 10010, then this is the 10000, and then here is all zeros. So all 3 of those are necessary to catch these tools. Now there may be other variants of tools that generate a different ticket option that I haven't seen. But this rule is pretty good for the most common ones, right? Invoke-Kerberoast, Rubeus, and GetUserSpns.py are the most common vectors for this attack. So if you use this rule in your SIEM, you'll be able to detect it. I would definitely recommend just doing the prevention here, right? Do the group policy, change the user accounts, just get this hash out of your network, make it an AES hash. That's where you should be. And then you can do the detection after the fact. And then you can also do this rule without any of this, just detect the ticket encryption type of 0x17, and then it's an investigation, right? You want to take a look at it because it might be some kind of hacker tool trying this after you've already blocked the attack from working. And that's basically it for Kerberoasting. I want to thank everyone for watching and subscribing. And please like the video if you like the content you see. It's really helpful for the channel. But I'll leave you once again with Hack the Planet to defend better.